Welcome back. This is lecture 11, and we're starting with the renin-angiotensin system. So, as indicated on your lecture outline, take a look on page 785 at figure 2019, upper right-hand corner. Recall, you already know quite a bit about this renin-angiotensin system, and I'm not going to go through all of those details again. Since we have this figure, though, let's focus on some new information about that renin-angiotensin system. You'll recall we've talked about this compound, we've talked about this enzyme called ACE, and now new information from this figure is where the ACE is coming from, where it's being produced. And notice in that figure then, about halfway down, that the ACE is being produced by capillaries in the lungs. So jot down that information in your notes. The ACE, again, is being produced by capillaries in the lungs. And now let's go down to the very lower right-hand corner of the figure, and we're looking at four specific effects of the renin-angiotensin system, so four bulleted effects. And here I would like you to enter into your notes that all four of these effects increase fluid volume in the body. All four of these bulleted effects, again, increase fluid volume. All of these conserve water or bump up, increase the amount of water that we have in our body. And let's consider then each of these effects individually. That first bulleted effect then, notice, is vasoconstriction. And the implication here, if you now glance over to page 784 and take a look at that lower left-hand portion of the figure, the implication on the subsequent page when they're saying vasoconstriction is vasoconstriction of both the afferent and the efferent arteriole, vasoconstriction of both types of arterioles. And is being shown in that figure. And as you'll recall from last time, the effect here is a decrease in GFR, a decrease in glomerular filtration rate, and if you think about it, this means that we're not losing plasma to filtrate as quickly. Plasma is not being converted into filtrate as quickly. And so we're conserving plasma, we're conserving water. Let's go back to page 785, back to the figure, and look at that second bulleted effect. And notice here, increased aldosterone secretion. And you guys know this one from previously hearing about renin-angiotensin system. And recall then that when we increase aldosterone secretion, we conserve water. That third bulleted effect then, increased ADH secretion. And again, you guys know from when we talked about endocrine system that when we increase ADH, we again conserve water. And then finally, that fourth bulleted effect of the renin-angiotensin system, increased thirst. And of course, this is also going to increase our body fluid volume, our body water volume, if you will. Going back to your lecture outline now, and notice we're next talking about tubular reabsorption, and notice also then that you're being directed back to page 783 and to table 20.1. Let's talk about the setup of the table for a minute. So notice off to the left, we have a column of substances, various chemical substances. Moving over to the center part of the table now, notice we have blood plasma, and we're looking at concentrations of these various substances within the blood plasma. By the way, you don't have to memorize any of these specific numbers, as we'll see in just a minute. But now compare concentrations of each of these substances in the plasma versus just to the right in the glomerular filtrate. And as you run down the table, you'll notice those concentrations in the plasma versus in the filtrate, those concentrations are exactly the same. And this just reinforces the fact that filtrate essentially is plasma. It's just in a different location. It's plasma that's been filtered out of capillaries. So realizing that, we can now ignore that plasma column, and what we want to do now is to compare the glomerular filtrate column with the urine column off to the right. And as you just kind of quickly scan down and compare a few of these substances, notice then in some cases there's a higher concentration of a substance in the filtrate, and in other cases a higher concentration in the urine. So let's talk about those substances then with a lower concentration in the urine. And think about what this means. If there's less of something in the urine than there is in the filtrate, that means that substance has to have been reabsorbed. And this is probably worth jotting down just so when you come back and look at this table, you have that point of reference. And so again, when there's a lower concentration of a substance in the urine than in the filtrate, the substance has been reabsorbed. Think about the example we talked about when we talked about reabsorption, tubular reabsorption. And the example was glucose. Take a minute now, find glucose down toward the bottom of the table. Compare the concentrations in the filtrate versus in the urine. And as we said, because glucose is something we want to keep, we don't want to lose it in our urine, we reabsorb glucose. We take it out of the filtrate that's moving through the tubule. We don't lose it as urine. We retain it by reabsorbing it. And again, take just a minute and make sure you're good with that particular concept and that particular example. So we retain glucose by reabsorbing it. And now let's just look at some other substances that are being reabsorbed. And let's go up towards the top and work our way down through a few. Notice then, and here again, you don't have to know the specific numbers, the specific concentrations, but notice we, in addition to glucose, we reabsorb sodium. And we reabsorb bicarbonate, HCO3 minus. Since we're on this table, on your lecture outline, let's jump over sodium and water reabsorption for a moment, and let's talk about tubular secretion. And think about what's happening here. And so substances with higher concentrations in the urine compared to the filtrate, substances with higher concentrations in the urine have been secreted. These are things, remember, that we want to get rid of, at least to some degree. And let's again just run down through the table and look at some specific examples. And so you can jot down in your notes then potassium, magnesium, sulfate, phosphate, potassium, magnesium, sulfate, phosphate, and then also down toward the bottom, urea, a waste product, which we'll talk about briefly, uric acid, another waste product, something else we want to get rid of, and creatinine, which is building up in the blood, which we want to get rid of. All of these substances are secreted into the tubule and lost in urine. And we'll end this lecture here.